Yeah, good evening all. Everyone can hear me? Online students. Okay, done. So let's start the session. So in today's class, we are going to work on the descriptive statistics using the Python. So in the last class, we have seen the descriptive statistics with respect to the data. And along with that, what are the different types of statistical analysis we can apply on the data, right? Now, if you recollect whatever we have discussed in the entire statistics step by step, I'm writing as a complete what are the topics we have covered in the statistics till now. The first one is what is the type of data? Okay, data. Data is of structured and semi unstructured. Okay, structured means which is in the tabular format. Unstructured means which is not in the tabular format or which is not having any format, either images or text or mails or comments or everything. This all comes under unstructured data. Structured data means which is in the tabular format. So data and what are the different types of data we have discussed. And within that structured data versus unstructured data, right? And along with that, we have discussed within the structured data, what is meant by a variable. Variable means nothing but a future, or which is also called as column name. Now we have discussed what are the different types of variables are available. Different types of variable. Within the different types of variable, we are having continuous and discrete. We have discussed about the continuous and discrete, right? So these are the things which we have discussed. And along with that, types of variables. After that, types of variables, we have discussed about the statistics. Before statistics, we have understand what is population and what is meant by sample. Okay. And next, we have understand what is meant by statistics. And within the statistics, we have seen the what is meant by types of statistics. Next one is types of statistics. What are the different types of statistics? Within the types of statistics, we have discussed with respect to similarly here that okay, types of statistics we have seen with respect to descriptive statistics and inferential statistics. Now, what is meant by descriptive statistics means just describing the data is called as descriptive statistics, and inferential statistics means in terms of inferencing the data, that is estimating the population data based on the sample data is called as inferential statistics. Next, we have seen with respect to now within the descriptive statistics, what are the different types of variables. Within that variables continuous and discrete. Now, next we have discussed about the measures of central tendency. Measures of central tendency. So which is measures of central tendency? Within that measures of central tendency, one, mean. Mean means average value, right? Second one is nothing but median. Median means centermost value. Next one is, third one is mode, most repeated value. Next, we have discussed about the after measures of central tendency, we have discussed about measures of dispersion or measures of shape, or sorry, measures of dispersion or spread. Measures of dispersion, this is called as measures of dispersion, or this is also called as measures of shape, sorry, measures of spread. Measures of spread means how your data was spreaded. Okay, how dispersion means how your data has been distributed. The meaning of dispersion is distributed. How the data was distributed. Okay, the meaning of dispersion means distributed. And we have discussed about the measures of spread. Within the measures of spread, we have discussed within that one, what is meant by minimum value. Two, what is meant by maximum value. Three, what is meant by with respect to is a range function. Okay, we have seen the range function. And next we have seen the deviation. After that, we have seen the mean absolute deviation. Mean absolute deviation. After that, we have seen with respect to mean square deviation. Mean square deviation, which is also called as variance or variance. And the seventh one is mean standard deviation. Next, we have discussed about the standard deviation. So mean deviation also comes here. So if you want mean deviation, always the mean deviation is going to be 0. Since the mean deviation is always going to be 0, that is the reason why we have got the mean absolute deviations and mean square deviation concepts. And finally, standard deviation. And next we have seen the same thing called as percentiles. Within this only the percentiles will be there. Okay. Within the percentiles, if 25th percentile or 50th percentile, these are special percentiles which are also called as quartiles. Using the quartiles, we are having interquartile range. Interquartile range value. And based on the quartiles and interquartile range, we are identifying the outliers. Outliers is not under the measures of dispersion. Using that, we are identifying. But that is not the part of the measures of dispersion. These are all the measures. We are able to identify this one. So these all comes under measures of dispersion, how the data was distributed. So based on your percentile values, based on your quartile values, we can identify. For example, if the quartile value says, for example, in a particular company, Q1 salaries of a persons are there, salaries of the employees. In a particular company, salaries of employees are there. Q1 value is 6,50,000. Assume Q1 value is 6,50,000. What is the meaning of that? In a particular company, Q1 is 6,50,000. What is the meaning of that? Means in that particular company, 25% of the people are having less than 6,50,000 salary. That is the meaning of that. In a particular company, median is 12 lakhs. What is the meaning of that? 50% of the people are having less than 12 lakhs. 50% of the people are having more than 12 lakhs. So we are able to understand the entire data, the distribution of the data. Okay, in the company, these employees are having this much of salaries like this. The entire data distribution we are able to understand based on the quartiles values. Okay, the maximum salary would be this one, the minimum salary would be this one, and quartiles 25%, 50%, 75%. All this tells us the with respect to. And if the standard deviation is very low in that company, the salary standard deviation is very low. Means almost everyone are close to the average. Means everyone they are having the equality. If the standard deviation is very high, means they are not having the equality. If some people are having very high salaries, some people are having very low salaries. If the standard deviation is almost close to 0, means everyone are having the almost same salary. Everyone are having the same salary. That is the meaning of standard deviation is equal to 0. Standard deviation is equal to 0 means there is no deviation. There is no deviation means there is no difference between the employees. All the employees are same. That is the meaning of that. So you are going to understand the entire data distribution by calculating these values, right? So these are all called as measures of distribution or the measures of spread, right? Now, next one is called as measures of shape. So you are going to see the measures of shape. Next one is comes under measures of shape. Now, what is this measures of shape tells? Within that, 1, skewness, your skewness, and 2, kurtosis. 2 is kurtosis. Skewness tells us whether the data is a normally distributed or not. Whether it is a left skewed or right skewed, or whether it is a normally distributed, right? So shape. Now, what is the advantage of normal distribution? So for if it is the data is normally distributed, we can calculate the probability directly, very simple way. If it is skewed data, we have to get the entire data records. And we have to apply the how many records are satisfying our requirement divided by total number of records. General probability concept we have to apply. But if you are having the data is normal, the probability calculation will be easy. Why, sir? If the probability calculation is easy means what happens? If the probability calculation is that way means what happens? What is the difference? That importance you are going to see in the inferential statistics. That probability calculation and whatever the p-value you have calculated from the Z table, right? All this importance you'll see in the inferential statistics. So here the measures of shape, that is skewness and kurtosis. So we are having within the skewness, what is the skewness we are having miss with respect to one left skewed, one is left skewed, one is right skewed, and no skewness, which is normal distribution or which is called as symmetrical distribution. Either symmetrical or unsymmetrical. Within the unsymmetrical we are having, so you can write like this. Within this, you can take again is a part where one, again within that one is with respect to symmetrical, one is symmetrical and one is non-symmetrical, which is also called as unsymmetrical. Unsymmetrical distribution. Skewness tells whether the data is symmetrical or unsymmetrical. Unsymmetrical is also called as skewed distribution. If the data is unsymmetrical, then it is called as skewed distribution. And this skewed distribution is again two types. One is left skewed, one is right skewed. Within the again skewed distribution, again subparts once again, right? And within the kurtosis, kurtosis says that whether the data is with respect to mesokurtic or leptokurtic or platykurtic, right? So different types of kurtosis. Now kurtosis tells about the height. Kurtosis is not having that much of importance, whereas remaining all of them are having so much of importance, but whereas kurtosis is having less importance. Now this first measures of central tendency, what are the measures of central tendency is there? This one is called as first business movement. First business movement. The measures of central tendency is also called as first business movement. Measures of dispersion. This one is called as second business movement. Means for, in the data we want to analyze means first we are going to analyze this one. After that we'll analyze this one. After that we are going to analyze that one, like that. So next, this skewness, what are the skewness is there? This skewness comes under with respect to the third business movement. The skewness is comes under third business movement. Third business movement is nothing but kurtosis. And the fourth business movement is called as kurtosis, right? So these are the things. Now next, with respect to whatever the types of variables we are having, continuous variable and discrete variable. So for different types of variables, we are having the different types of plots. Next heading is plots, types of plots. In the plots, we have discussed what are the different types of plots we have discussed is the first one is for continuous variable histogram. Before histogram, first we have seen the bar plot. Bar plot, this is applied for the discrete variable. This is for the discrete variable. Second one is histogram. Just to focus on the board, whatever I'm writing, just focus and recollect whatever we have discussed, everything. No need to write. I'm going to upload this one in the drive. Whatever I'm writing on the notepad, I will upload immediately. For your purpose only, I'm typing now. I'll upload for in your drive automatically, right? So histogram is for continuous data, right? So the structured data can be discrete, continuous, and the third one also possible. One is continuous, second one is discrete, and what is the third one is possible? Time series. The time series also structured data only. Time series also comes under structured data, right? Whatever we are having the types of variables, I'm writing the types of variables like this. One is called as continuous. Second is called as discrete. One is called as discrete. The third one is called as time series. right? These are the different types of variables. So within the time series, again, I'm having, within the discrete variable, again, I'm having with respect to one called as discrete count. And within the discrete variable, one more is discrete categorical. These are all the things we have covered, right? So discrete count and discrete categorical. Discrete variable is also called as quantitative data. It is also called as qualitative data. It tells about the qualitative data. And whereas continuous variable is also called as quantitative data. This is also called as quantitative data, right? So one is called as qualitative data and one is called as quantitative data. And within the discrete, I'm having discrete count and discrete categorical. Again, within the discrete categorical, again, it is furtherly splitted with respect to one called as nominal, and the second one is ordinal. Within this ordinal, right? So for different types of data, we are going to represent by using a different plots. For continuous variable, we are going to use the histogram. For discrete variable, we are going to use the box plot. For continuous variable, we are going to use one more, which is called as box plot. One more called as box plot. This is also applied on the continuous variable only. Okay. This is also applied on the continuous variable. Now, what is the use of histogram? Histogram is used to check, use it to check whether data is normally distributed or not. To check whether data is normal or not. By seeing the histogram, we can say that whether if it is a symmetrical or non-symmetrical, normal or not. Right? Using the box plot, we are going to check whether the data has outliers or not. To check whether whether the data has outliers or not. To check only. How many outliers? We are not going to check here. Whether the data has outliers or not. Yes or no. If the dots are available, means outliers are available. If the after the output variable, the dots are not available, means output variable is not available, means outliers are not available. For time series variable, we are going to use the line plot. Line plot is for the time series variable. For time series, we are going to use the line plot, right? Is that clear? Discrete data is quantitative or qualitative? Quality. Discrete means quality. Quality means whether it is a good quality or a bad quality. Good or bad comes under what? Text data. Text means discrete only, right? Simple. Qualitative, quality. Whether good quality or bad quality or worst quality. We are going to say how is food. I'm asking what is the quality of the food or what is the quality of the class. You are going to say good means good, bad means bad, which is a text data. Text data means discrete data. Discrete is called as quality. So no need to buy her that one. Quantity. If I ask quantitative means quantity. Quantity means how much quantity you want. You say number wise. You will not say good quantity I want, bad quantity I want. You can't say that quantity in terms of like that, right? You'll say either I want 2 quantity, 3 quantity, or 10 kgs, 5 kgs, something you are going to say. By using the number only, you can say the quantity. So if you want to have how many apples you want, quantity, how many quantity of apples you want means you are going to say 10 apples I want. Quantity means number only. So number comes under continuous. Okay. Is that clear? Done. Next. So this is with respect to that different types of plots. Next, after the plots, we have discussed what is meant by probability. Okay. Within the probability, we have seen the probability theorems, different types of probability theorems. What are the probability theorems we have seen? One is called as additive theorem, and the second one is called as multiplicative theorem. Multiplicative theorem. Next one is multiplicative theorem. So these both theorems, whatever the theorems we are having, the both theorems are applicable when the data is independent to each other. So the two events should be independent to each other, where this L2 theorem is nothing but probability of A plus probability of B minus probability of A or B, right? Which is nothing but probability of A and B is equal to, what is the probability of A and B is equal to probability of A plus probability of B minus probability of A or B. Whereas coming to this probability of A or B, which is equal to probability of A into probability of B, that is multiplicative theorem. So two types of theorems we have discussed. Probability theorems, whatever the theorems we are having within the probability theorems. The first one is additive and the second one is multiplicative. And next we have discussed what is meant by probability distribution. What is meant by probability distribution? Within the probability distribution, we have seen the discrete probability distribution, discrete probability distribution. And second one is continuous variable frequency distribution, continuous variable for continuous probability distribution, right? So two types of distributions we have seen. And along with that, we have seen how to calculate the probability. How to calculate the probability. How to calculate the probability if data is normally distributed. If the data is normally distributed, how to calculate? If the data is not normally distributed, we can't apply this rule. If the data is normally distributed, then what we can do? Then what are the options we have discussed? One, by using the z-score. First, we are going to use the z-score. Second one is either we are having 68, 95, 99.7 rule. Or out of these two, any one we are going to apply and we are going to calculate the probability. These both the things are applied only if the data is normally distributed. So these are the things which we have discussed in the entire statistics, right? Is there anything left apart from this? Yes. Next, coming to here in the deviation or this one, with respect to y, we are considering n-1, n-1 for sample, n-1 for sample variance, the reason behind of n-1 for sample variance, and also for sample standard deviation, For both the reasons, for both of them, we are going to use n-1, and we have seen the reason behind that. What is the reason behind that? Right? Why we are going to consider the n-1 for sample variance and for sample standard deviation, right? And next, we have discussed with respect to what is frequency distribution. What is the difference between the frequency distribution versus probability distribution? We have seen what is meant by frequency distribution. Next, types of frequency distributions. What are the types of frequency distributions we are having? Frequency distribution, out of which one of them is discrete frequency distribution. For discrete variable, discrete frequency distribution. And the second one is continuous frequency distribution. For continuous variable, continuous frequency distribution. Right? And these are the comes under types of frequency distribution. Next, we have seen what is the difference. What is difference between frequency distribution? What is the difference between frequency distribution versus what is the difference between frequency distribution versus probability distribution? Probability distribution. What is the difference between these two? Okay. Distribution. Right? What is the difference between the frequency distribution versus probability distribution? On the x-axis, distribution of the data we are going to consider. In the y-axis, in the frequency distribution, we are going to consider frequency. In the probability distribution, we are going to consider in the probability. The difference only will be in the y-axis. X-axis will remain same. X-axis is not going to change. X-axis, the distribution of the data will be there, right? So these are the things which we have discussed. And along with this, next, coming to the bivariate analysis, covariance. We have discussed what is meant by covariance. And next one is correlation. Right? Still? Yeah, a model distribution, that is modes only, different types of modes that comes under modes. Unimode, bimode, multimode, everything comes under modes, right? Next, we have discussed about the different types of distribution of the data. Next one is different types of distribution of data. What are the different types of distribution of data? Means we have discussed one. The first one is called as uniform distribution. We have seen what is meant by uniform distribution, right? And the second one, normal distribution. And we have seen with respect to skewed distribution. And fourth one is standard normal distribution. What is standard normal distribution? Right? So these are the different types of distribution. And next, we have discussed what is an outlier. Finally, what is an outliers and how to calculate outliers, how to identify outliers, or how to calculate the outliers for a given data set. How to calculate outliers. Right? So these are the overall which we have discussed in the entire statistics within the descriptive statistics, right? So generally this entire statistics, whatever we have discussed, the same thing, including the descriptive statistics and inferential statistics, the same thing in the BTech we'll discuss for 6 months, right? In one semester, we'll have the statistics subject. Now, if you open the, I have uploaded few textbooks. Already I have uploaded the textbooks in the drive. And if you open the textbooks, okay, what are the textbooks I have uploaded in the drive? Okay, this is one of the most standard textbook. Okay, and you can select whatever the textbook you want. That is your choice. It is not mandatory that you have to use this textbook only. You can select as per your choice. Now, if I open this let us see one by one. The first one, what is statistics and why we'll use the statistics, and we'll explore and we'll estimate and we'll do all these things. And the second one is how many types of variables are there? Univariate data. Univariate data means single column data. Bivariate and multivariate. Bivariate means you are going to do the bivariate means two variables you are going to consider at a time. Multivariate means multiple variables you are going to consider at a time. Next, we have discussed about the quantitative data. Quantitative data means quantity, numbers. Within the numbers, we are having continuous data. Discrete count also comes under quantitative only. Discrete count. And qualitative ordinal and nominal. This both comes under categorical, right? Now, time series data, what is the difference between the time series data versus cross-sectional data? Cross-sectional data means it is independent of time. Time series data means it is dependent on the time. We have discussed. Next, distribution of the data. I have explained you the what is meant by distribution and what is meant by histogram. So histogram is nothing but frequency distribution of a continuous variable. And what is meant by normal distribution and what is meant by skewed distribution and what is meant by bimodal distribution. Bimodal distribution means multiple modes are there. Two modes are there. And what is meant by outliers. I think everything I have explained, right? Next, If you see with respect to chapter number 4, here I have discussed you what is meant by average value, what is meant by median, and what is meant by mode. Here, if you observe, there is a weighted average. Weighted average means if the weightages are different. For example, you are having your internal exam or 40% weightage, external exam 60% weightage. Then what is the how we are going to calculate the weighted average? 40% of the internal marks we are going to multiply, 60% of the external marks we are going to multiply, divide by the total weight, right? So that is called as weighted average. So weighted average formula is sigma Wx divided by sigma W. Weighted average formula is sigma Wx divided by, guys, please write weighted average sigma Wx divided by sigma W. Okay, today I'm not having the pen, so something I'm trying, right? So sigma Wx by sigma W means weighted average. Whatever the weighted average you are having, that is W1 x1 plus W2 x2 plus divided by W1 plus W2. Okay, this is not U, W. Okay. As offline students can see that there is no pen and I'm trying to write with my hand on the touch screen. For offline students, for online students, I'm saying this one. Guys, I'm not having the pen. If the letters are not that much of clear, just understand. Okay, today I have forgot the pen, right? Is that clear? Next. So now what is this weighted average? That is W1 x1 plus W2 x2. Just a minute. Okay, W1 x1 plus W2 x2. For example, let us take like this. 40% weight was given for your internal, out of which out of 100 you have got 70 marks, which is of 40% weightage. Whereas external marks, out of 100 you have got 90. The weightage of this one is 60%. This is 60% weightage. Now both of them are having different weightages. So in this case, what we have to do first, weightage of the first one. What is the weightage? That is 40%, which is equal to 0.4%. 40%. Percent means percentage you have to calculate, which is equal to 40 divided by 100, which is equal to 0.4, right? 0.4 into 70 plus 0.6 into 90 divided by 0.4 plus 0.6, which is nothing but 28 plus 54 divided by 1, which is 28 plus 54, which is equal to 82. So this is your marks, 82 marks. So if you take directly, you'll get the 80. This is called as 70 plus 90 divided by 2. If you take like this, 70 plus 90 divided by 2, what you are doing indirectly, you know, in that you are taking 50% weightage for this and 50%. Both are having the equal weightage. The meaning of arithmetic mean. What is the meaning of a normal mean? Whatever we have completed earlier, the meaning of that one is 0.5 into 70 plus 0.5 into 90 divided by 0.5 plus 0.5. That is 35 plus 45, which is 80. This is the meaning, actual meaning. If you take directly the average of 70 plus 90 divided by 2, the actual meaning is this one. What is the actual meaning is both are having the same weightage. By default, whatever the general average will take, that average says that everything are having the same weightages. Weighted average says particularly this is having a different weightage, this is having a different weightage. So this part, whatever this one is there, this one, whatever I have calculated here, this is called as your arithmetic mean. This is called as weighted mean. This is called as weighted mean, and this is called as arithmetic mean. So, sir, when we are going to apply the weighted mean, when we are going to apply the arithmetic mean, if everything are having the same weightage, then go with the arithmetic mean. If everything are having a different weightage, then apply the arithmetic mean. For example, in the in the interview, Python is having 30% weightage. Machine learning is having 50% weightage. SQL is having 20% weightage. Then three of them are having different weightages. Since three of them are having different weightages, you can't combine three of them and you can't apply the arithmetic mean over that. In that case, we have to go with the weightage, weighted average. For example, there is no difference. Everything are same. I'm asking generalized question. I'm asking everything are same weightage. Then go with the average. Total how many questions you have answered divided by number of questions. That is simple. So with respect to that is called as arithmetic mean, and this is called as weighted mean. Weighted means weighted average that generally will apply in the internal exams and external exams. In our college, we have done the internals and externals, right? There it is applying the weighted average concept, right? For example, if both of them are having 50-50 weightage, let us assume this one is 50% and this is 50%. What is the meaning of that? It is equal to normal average only. If both of them are same average weightage, it is normal mean only. If you apply weighted average also, answer will be the same. If you apply normal mean also, answer will be the same. Right? Is that clear? So next, so that is at the weighted average and median. Median is completed, mode is completed. Next, percentiles. I have told you what is meant by percentile, quartiles, box plot. Right? Next concept is variability. Variability, where I have told you what is meant by standard deviation, what is the formula for that, and what is meant by deviation and what is meant by variance. That is nothing but mean square deviation. Next, how to interpret the standard deviation. Means from the standard deviation, what you are going to understand. What standard deviation tells us. That is called as interpreting the standard deviation. Interpreting means from that what you are understanding. Right? Next, what is the difference between a sample standard deviation versus population standard deviation? That also I have told you. And what is range and quotient of variance? Quotient of variation. This one also I have told you. That is mu divided by sigma into 100 is called as quotient of variance. Okay, variation. So this part also completed. Next, coming to the chapter number 6, probability. I have told you what is meant by probability and how to calculate the probability. Within that probability, what is the different types of theorems are available? That is with respect to called as multiplicative theorem and additive theorem, right? Next, coming to the next chapter, here we have in this case, we are having with respect to normal distribution, standard normal distribution, and how to calculate the z-scores along with that, right? So we have discussed, to be more precise, in this textbook, up to here, we have discussed up to page number 180, according to this textbook. Okay, 7 chapters was completed. As per this textbook, 7 chapters are completed. You can select any textbook of your choice. In the entire world, you can select. Okay, any textbook, because the statistics remains same. Okay, is that clear? And this is quotient of variation also comes under this. Here only the quotient of variation comes. So quotient of variation. Okay, quotient of variations also comes under measures of dispersion only, within the measures of dispersion, right? Is that clear, guys? Any questions till now, whatever we have discussed? Now, sir, earlier we have discussed the univariate. As you told that we have completed univariate, bivariate. Bivariate, only the covariance and correlation. Only 2 things you have told. Now coming to this multivariate. Now in the multivariate, how we are going to do and what are the things are available? For univariate, so many things we have discussed. Okay. For bivariate, only 2 things you have told. One is called as covariance, one is called as correlation. Only 2. These 2 only comes under bivariate. Now comes under multivariate. What is then multivariate? Multivariate means applying the analysis on the multiple data, means that is more than 2 variables, selecting more than 2 variables at a time. That is x1, x2, x3. If you are having, let us assume 3 variables are there or 4 variables are there. Now you have to apply the analysis on the 4 variables at a time. Then it is called as multivariate analysis. How we can apply? Very simple. Very simple. Simple is nothing but you have to take a matrix. One matrix with rows and columns. Okay, where in the rows heading you have to keep x1, x2, x3, x4. Along with the row names also x1, x2, x3, x4. Okay, you have to create a matrix. And in this matrix, the first one is correlation between x1 and x1. What is the correlation between two variables? Correlation between two variables is nothing but sigma of covariance. What is meant by correlation? Formula of correlation, that is covariance of x comma y divided by sigma of x into sigma of y. Now, if it is both of the same variables, covariance of x1 versus covariance of x2, I mean x1 versus x1, then variance of x1 only. Simply it is nothing but variance of x. Both are same only now, x and x. X and x means both are same is nothing but variance of x. Divide by sigma x, sigma x. Sigma x is nothing but sigma square x. Sigma square is x is nothing but variance of x. Variance of x divided by variance of x. Then what is the value? 1. So this value is going to be 1. The correlation between the same variable will be 1. Okay, this 4 will be always 1. This is the correlation between x2 versus x2. This is the correlation between x3 versus x3. This is the correlation between x4 versus x4, the last one. Right? This is the correlation. Now, this one, what is this value? Correlation between x1 versus x2. What is this one? Correlation between x1 versus x3. What is this one? Correlation between x1 versus x4. Now, you are applying everything at a time now. So, this is called as multivariate analysis. Multivariate analysis is nothing but matrix. Correlation matrix is called as multivariate analysis. If you calculate the correlation. If you calculate the covariance, it is called as covariance matrix. Covariance between x1 versus x1. Covariance between x1 versus x2. Covariance between x1 versus x3. Covariance between x1 versus x4. If you're calculating the covariance means it is called as covariance matrix. If you're calculating the correlation means it is called as correlation matrix. So now, what is bivariate analysis we are having? What is the bivariate analysis? One is called as correlation. Second one is called as covariance. One is called as correlation and one is called as correlation. And coming to the multivariate analysis. Multivariate. If you go with the multivariate, within the multivariate, what is the first one? Correlation matrix. Earlier you have calculated between two variables only. Now you are calculating between the multiple variables, not at a time. 2 by constraint 2 only. x1 versus x2, x1 versus x3, x1 versus x4. Constraint 2 variables at a time, you are calculating the correlation. But everything you are keeping in a single matrix. That matrix is called as multivariate analysis. Correlation matrix and covariance matrix, these both comes under multivariate analysis. Is that clear? Bivariate analysis is correlation and covariance. Multivariate analysis is matrices. They're matrices. In the matrices, we are going to calculate between one variable to another variable every time. Is that clear? Now, if you observe this matrix, what are the matrix we are having? That is x1, x2, x3, x4, x5. If you are having any variable also, no problem. Okay. This one, this is the correlation between x1 versus x1. I told you. Now, what is this one? Correlation between x1 versus x2. Now, what is this one? x2 versus x1. Both are same. This one and this one are same. The relation between 1 and 2 and 2 and 1 also will be the same. Right? So, that is the reason in the correlation matrix or covariance matrix, upper triangle matrix and lower triangle matrix will be the same. In the both the cases, upper triangle matrix and lower triangle matrix will be the same. Because this is the correlation between x1 versus x2. This is the correlation between x2 and x1. Now just apply the logic. You are calculating the correlation of x1 and x2. What is the formula for this one? Tell me what is the formula? Covariance of x1 comma x2 divided by sigma of x1 and into sigma of x2. This is the formula. Now, what is the correlation of x2 comma x1? Which is nothing but covariance of x2 comma x1. Covariance of this one of x1 comma x2. What is the formula? Sigma of x1 minus x1 bar into x2 minus x2 bar. What is the formula of this one then? Sigma of x2 minus x2 bar into x1 minus x1 bar. Both are same only, na? If you multiply a into b or b into a, both are same only, right? Similarly, divided by sigma of x2 into sigma of x1. If you multiply this one to this one also, this one to this one also same. So above formula and below formula both are same. This one and this one both are same. There is no difference. The correlation between x1 and x2 and x2 and x1, everything will be the same. So that is the reason upper triangle matrix and lower triangle matrix will be the same. In a correlation, in the correlation matrix, write in the notes. In the correlation matrix, the upper triangle and lower triangle will be the same. Upper triangle and lower triangle values will be the same. Along with that, diagonal values is going to be 1. Along with that, diagonal values is going to be 1. Right? Example, you take an example. x1, x2, x3. x1, x2, x3. Right? So this is the first one is correlation of x1 versus x1, which is equal to 1. Correlation between x2 versus x2, 1. Correlation between x3 and x3 is 1. This is called as correlation of x1 comma x2, which is correlation of x2 comma x1, both are same. This one and this one are same. Similarly, this is correlation of x1 comma x3. This is the correlation of x3 comma x1. These both are same. This one and this one are same. Similarly, this is correlation of x2 and x3. This is correlation of x3 and x2. These both are same. So above triangle and below triangle will be the same. Upper triangle and lower triangle of the matrix will be the same. And diagonal values are going to be 1 in the correlation matrix every time. Is that clear? That is multivariate analysis. Done? So let's do whatever we have discussed till now, everything in the Python. Let's start. Yes. Sorry. One second, slowly. X1, Y1. What is X1, what is X2? Tell me what is those. First, according to what is Y1, that is name, that is output of what is that? Then normal only, na? According to you, whatever you are considering, that one. Covariance you are considering means covariance, correlation you are considering means correlation. Right? Is that clear? Clear, guys? Now, as in the chat box, one of the student is asking, take an example and explain, sir. Take an example. Choice is yours. Take x1, x2, x3. Take some values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. If you're interested, take these numbers. Not interested means select your numbers. What are the numbers? Answer is going to be, formula is same. If you take big numbers means calculation will, you have to open the calculator. If you take simple numbers means no need to open the calculator. That is the only difference. Right? Remaining will be the same. Right? Now, here, whatever I'm considering, Now, x1, x2, and x3. Calculate the correlation of x1 and x2. What is the correlation? Just calculate. Similarly, what is the correlation of x2 and x1? Calculate after the class. Okay, after the class, just calculate. Apply the formula. Whatever the formula you are having, apply the formula. Separately, you calculate the covariance of x1 and x2. Separately, you calculate the covariance of x2 and x1. Separately, you calculate. You will only get now. Similarly, if you want the correlation of x1 and x1, calculate. You already know the formulas, right? You already know the formulas. Just apply the formula. Okay, just apply the formula and calculate each of them separately. This value is going to be 1 and these both values will be same. These both values will be the same. And the value this one and this one also you are going to get 1 for this example. For this example, you will get 1. But generally, these both will be the same. These both will be the same. And this will be obviously 1. 100% it will be 1. But these both will be the same. Right? Is that clear? So let's start the coding in the Python. Now I'm going to load the data set called as tips.csv file. This is one of the data set. Okay. So import pandas as PD. Right? Already we have completed the pandas part. So I'm importing the pandas, and within that, how to read a CSV file also I have told you. That is td.read_csv to read a CSV file. And here you have to write the path if it is not in your working directory. If it is already in your working directory means wherever your Jupyter notebook and this CSV file, if both of them are located in the same folder, then you don't need to write the path. If both of them are located in a different folders, then you have to write the path. In my case, this is my Jupyter notebook. Whatever the Jupyter notebook I am going to work is, this is the Jupyter notebook. Okay. This is the file which I am working, and this is the data set. So these both of them are in the same folder. In the same folder, it is there. Since both of them are in the same folder, I no need to write the path. If I write also, no problem. If I write also, no problem. Right? Since both are in the same path, I no need to write the, since both of them are in the same folder, I no need to write the path. Directly, I can write the tips.csv. And df.head. What is meant by df.head? First 5. It is going to give first 5. Why first 5? Because whatever the data set here, tips.dataset is there. In this, whatever the data set I'm having, total bill tip, gender, smoker, day, time, size. This, whatever the columns are there, whether I'm loading a correct data set or a wrong data set. Maybe I may load a wrong data set sometimes. To check myself, whether if I don't write like this, for example, if I don't write like this, it will load. Now, after loading, whether I have loaded a correct one or wrong one, how I can know? So I have to print, right? I have to print whatever I have taken. I have to print that one. Instead of writing df, if I write df, what happens means first 5 records will be printed. At the same time, last 5 also will be printed. In between dot will be there. There is no use. If it is printing first 5 and last 5 means there is no use. For me, whether I have loaded a correct data set or not, only I want to check. So for that, what I'm going to do is just I'm going to write the head function. Within that 2 records, if I write also sufficient for me. If I write even 1 record also sufficient for me. Whether I have loaded a correct data set or not, only I want to see. So I have loaded a correct data set. So to check the correct data set, we are using the head function. Right? Next one is info. Info means I'm going to check about my variables. That is shape of the data. That is 244 records are there. Records are 244. Columns are 7. And these are all the column names. 7 column names. And out of these 7 column names, 2 of them are float. Float means continuous variable. Whenever you see the float, it is a continuous variable. Object means discrete categorical variable. Int means whenever there is a int is there, that you have to clearly see the data, see the variable name, size. So before understanding the data types, what we have to do is first we have to understand the data. First, we have to understand the data. What is this data and what is this data set for and what is the each column? So this is called as tips data set. What is this data set means? In US, there is one restaurant. In that particular restaurant, one waiter has collected the information. What is the information he has collected is with respect to whoever has paid him. The total bill amount is there, right? Some bill amount in that restaurant, they have something, right? Either dinner or lunch or something. After that, they have paid the bill. Whatever the bill amount they have paid, he has taken that bill amount. Okay, he has collected that information, bill amount along with the tip. Whatever the balance tip amount they have given for that. And whether the person, whoever has paid the bill, whether the person is a female or a male. Okay, whoever has paid the bill. Of course, everyone knows that most of the males only will pay the bill. That is common. Okay, so whether it is a male or a female, so that is the one. And second, whether the person, whoever has paid the bill, whether he is a smoker or a non-smoker. Here we are having whether the person is a smoker or non-smoker, and the day, on which day they have came for the restaurant, and time, whether it is a dinner or lunch. In that particular restaurant, only dinner and lunch is available. No snacks, no breakfast, nothing is there, right? And the size means total how many members has came. Means this particular record says that total 2 members has visited on a Sunday for a dinner time, and the person who has paid the bill is female person. And sir, 2 persons, out of which 1 person is female, they have paid the bill. Who is the other person? That is not important for us. He has not collected. If he has collected, we can analyze. If he has not, there is no data from where I can analyze. In the data set, that is not there. So this is one more where total 3 members has visited. Out of 3, 2 might be female, 2 might be male. Anything can be there. Any possibilities, or 3 of them may be males only. Who knows? That we don't know. But what are the data set is there? Total 3 members has visited for the dinner time on the Sunday, and the bill was paid by the male, and the bill amount was $10.34. 10.34, $10.34, and they have given a tip of 1.66. So this is the information he has collected. Just this is the information he has collected. Now, using this information, we are going to do some kind of analysis. Right? Now, here, so this is the data set. Now, in the data set, total bill means generally it will be in terms of dollars with cents. So generally decimal value will be there. Float, it should be a float. Correctly, it is given the float. So data type is correct. At the same time, column name is also correct. Both are matching. For example, if it is not matching, assume that in this data set, one of them is having 10, TEN like this. Then you will see the object. What is the data type you will see? Means object you will see. How the total bill and object? Means somewhere there is a wrong. That you have to check. That is called as data cleaning. If it is wrongly given the data type, then it is called as wrong data. That wrong data you have to convert to a right data. That is called as data clean, that we are going to discuss in the further class. As of now, I have taken a correct data set, clean data set. Unclean data set, worst data sets, and how to clean that one. That is next class. In the further class, we'll discuss that one. How to clean the data. That we'll see in the next further classes. So if the data set was wrongly given, then we are going to clean the data. Right? So we have to compare whether this total bill means generally total bill should be as a float value. Data type is also float. Okay, matching. Tip means generally the tip amount will be along with the dollar cents also they'll give as the tip amount. Yes, that also should be as a float. Yes, it is also matching. Gender should be with respect to that is either male or female. That is a categorical variable. Object, it is also matching. Smoker, object. Day, object. Time, object, because it is a dinner or a lunch. So object, categorical, this is also matching. Next, size, which is a int. Now I am opening like this. Okay, size 2.5 size is possible. Is that possible? No, because size. Now tell me what is size. It is a discrete count variable. Now whether it is a discrete or continuous, it is a discrete variable. This is 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 continuous variable, and this is continuous variable. So in the given data set, continuous variables are there. Discrete categorical is there. Discrete count also is there. Is that clear, guys? So in this way, we are going to identify the data types and the data, understanding the data. This is the first step of the data science project. For doing any analysis, first we have to understand the data. Then only we can process. If you don't understand the variable name, then how you can classify whether it is a discrete count or discrete categorical, or whether it is a continuous? For example, I have not told you what is meant by size. I have not explained this one. Then how you can know that whether it is a continuous or whether it is a int type only? Here, for example, let us take like this. 2.0 is there. 2.0. 2.0 means 2 only now. But 2.0 is there. Or assume that 2.1 is there. Assume like this. And you have got the size as the float. In the given data set, you have got here the answer as float. Hey, how the float can be there? Size means a total how many people has visited the restaurant is called as size variable. The size variable number of people can be either 1 or 2. How 1.1 or 2.1 will be the float? Means wrong is there. Means there is something mistake in the data. Where there is a mistake, whether that might be in the first row, there might be in the last row, or it might be in the center. Somewhere it will be there. Some mistake is there. Mistake is that we are going to write in the note. Okay, in this data, in this particular column, there is a mistake. We have to write in the notes. Notes is nothing but in the Jupyter notebook here we have to write. Like by keeping the markdown, we are going to write the whatever the things we have observed, we are going to write that one. Once we write that one, according to this, we are going to do the data pre-processing. Whatever we have observed based on that data pre-processing will be there. Right? Now, here, now continuous variable. First, I'm going to take the length column. Length column is nothing but entire data. Length means nothing but entire data, total length. That is 244 records. Why I have calculated length? Because mean. What is meant by mean? Sum of the values divided by total number of values. For example, here, this is there. This particular column is there. This particular column you are having in terms of, this is the entire 244 records. I want the average of this total bill. What is the average? First, I have to do the sum. After doing the sum, I have to do the divide by total. All right. Now the same thing. First, I'm going to do the sum. How to do the sum for that particular column only? So how to extract the only that column? For a single column with all the rows. How to extract the single column with all the rows? By writing the single column name. This already I have told you in the pandas. How to extract the data for a single column. Right? DF of total bill. Now what is meant by up to DF of total bill? Up to this. It will extract the total bill entire records. All the records values. Right? Dot sum. What is meant by dot sum is it is going to do the summation. Total. Total is 4,827.77. That is the total. Now, total divided by length function. That is nothing but 4,827.77 divided by 244, which is nothing but 19.78. That is the mean value. So the same thing I'm going to get by using the mean. Dot mean also will give the same answer. Same to same answer. Because in the backend, it is going to apply the same logic. In the backend, first it will calculate this one, it will calculate this one, and it will divide. In the backend also, it will do the same. So dot mean means average. Next, dot median. What is meant by median? Center position value. So it is going to take the center position value. First, it will make them in the order way. In that center position, whatever the value you are going to get, it is going to calculate. Sir, whether it is a correct answer or wrong answer, how I can know? So whenever you want to practice or whenever you are learning the statistics for the first time or for any new one you are learning for the first time, if you take a large amount of data for calculating, it will take so much of time. Okay. Then what we have to do is we have to select a small data set. See, I have created a small data set like this. Now, for this data set, 1, 2, 3, 4, 5. For this DF of X, if I ask DF of X dot mean, can you calculate mean? What is the mean? 1 plus 2 plus 3 plus 4 plus 5, that is 15. 15 by 5, which is nothing but 3. You will get directly. Logic is same only now. If you apply that on the big data set also, mean is concept is same. If you apply on the small data set also, meaning is same. Learning that one is easier. Learning this one is easier. When we are learning something new, we have to go with the simple examples. We should not select ourselves the complex examples. We should not get confused ourselves. When we are learning new things, we have to take a simple examples so that The mathematical calculations we can do, at the same time coding also we can do, and we can check both of them are giving the same answers or not. Now similarly, what is the median of x? df of x dot median. What is the median? 3, which is the center position value. For this one, what is the median? First, you have to make them on the ordered array. Ordered array means 6, 10, 14, sorry, 6, 10, 10, 14, 20. Now, what is the median for this? 10 will be the median. So just calculate df of y, take the y column and apply the median 10. First, we have done the manually. After that, we have checked in the code whether that answer is matching or not. If you do a small data set, calculations will be easy. If you take a large data set like this, what happens? If I explain on a small data set, students generally will not be satisfied. So they require one case studies. If I say case studies, projects, these take words for them very much interested. But actually, simple examples make the subject very simple. Okay, if I say case studies, take this much of data, this one, there will be no use. When we are learning, miss, go with a simple example. After learning, we want to check ourselves whether we have done a correct one or wrong, miss, then slowly increase the level of difficulty in the questions. Don't directly try with a large data set of 10,000 records or 20,000. Just try with 100 records. After that, try with 200 records. Slowly you increase the level of difficulty. Multiple times you will practice, automatically difficulty level also will be easy. That is the way of preparation. For doing this one, we require so much of time. So we have to dedicate the time. Right? Generally, if I'm the student, miss, I used to do like that. When I'm converting from non-IT to IT in the data science, at the time, for me also statistics is entirely new. As yesterday, one of the students has asked me, sir, statistics, multiple formulas are there, though we have to remember all these things. How, miss? Just we have to practice. I used to work on a small data set. First, 1, 2, 3, 4, 5, 6. Okay, now let us try with one more. I'll increase the one more record here. 2 more records. If even number of data points are there, miss, what happens? If odd number of data points are there, miss, what happens? I used to practice in that way. So for practicing mean or median or mode only, it will take for me 1 or 2 hours. No problem. For me, time is not important. Understanding the concept is important. So for that, I have to dedicate the time. So that is the thing which I used to do. That is my way of preparation. I'm saying about my way of preparation. Every single person is having their own unique way of preparation. You prepare as per your choice. Okay, whichever you feel easy, prepare in that way. But remember, don't by heart. If you by heart, miss, temporary purpose will be solved, not the permanent purpose will be solved. That is important. Right? Mean and median. Next, what is the next one? Mean, median, and mode. Next one is called as mode. So for example, if you tell it this one, in this particular variable, whatever the df of y is there, the same df of y dot mode. I'm applying the mode on the y variable. Now y variable, what is the repeated one? 10 was repeated. So 10 I'm going to get the 10. Sir, here 10 is okay, sir. But in the x, nothing is repeated now. Now, if I ask in the x, what is the answer I will get? There is with respect to everything of same now. So you will get all the values. Every value you'll get. Right? So here nothing was, if in this at least one of them is second time repeated, then only it is going to select. For example, sir, here, let us assume like this. Sir, 10, 10 and one more take 14, 14. Take 14, 14. Now 10, 10 is there, 14, 14 is there. Now what is the mode? 10 and 14. Both is the modes, right? Now let us ask the same question. If I ask df of y dot mode, I'll get 10 and 14, both of them. Is that clear? I will check like this. Bimodal, unimodal, multimodal. Multimode means, for example, if I take one more also, repeat, that is 10, 10, 14 and 6 and 6. You repeat 6 also. That is 6, 6. 2 6s, 2 10s, 2 14s are there. And this one also you are having one more because otherwise it will throw the error. Both the lengths should be equal. Now you are having in the y variable 2 10s are there, 2 14s are there, 2 6s are there. Now what is the mode? What is the mode of y? 6, 10, 14. 3 of them will get. 3 of them you will get. Within that, you want only the 6. Now what we have to do? What is the index number of 6? Row index number of 6? 0. Just apply the 0. How to apply the index number? We have discussed, right? In the pandas. Apply the logic. Is that clear? So mean, median, mode, calculation. Now next, coming to the minimum value. What is the minimum value of x? In the x, what is the minimum value? 1. So df of x dot min. I'm asking dot min. Now what is the minimum value? 1. Similarly, df of x with respect to max. What is the df dot x dot max? What is the maximum value in the x? 6 is the maximum value. 6. Okay. If 6 is there means 6, 5 is there means 5, whatever is there. Okay. For example, let us take like this. One more example. Right? Minimum value is 1, maximum value is 5. Now, what is the range? Range is nothing but maximum value. Take the maximum value minus what is the minimum value? df of x dot min. So first it will calculate the maximum value, that is 5, minus what is the minimum value? 1. 5 minus 1, which is nothing but 4. This is the range formula. Next, coming to the variance. Now, 1, 2, 3, 4, 5. For this, calculate the variance on the spot, please. Just do the calculation for x variable. 1, 2, 3, 4, 5. Calculate the variance. Calculate the population variance. Calculate the sample variance. Both of them. Do fast. Just in 2 minutes. Population variance, you are going to get 10 by 5, which is equal to 2. Sample variance 10 by 4, which is equal to 2.5. Why I have selected 1, 2, 3, 4, 5 means that is the reason. Very simple. X bar is going to be 3. 1 minus 3 is minus 2, minus 1, 0, 1, 2. X minus x bar whole square means 4, 1, 0, 1, 4. Total is 10. Variance formula, population variance formula is 10 by 5, which is equal to 2. Sample variation formula is 10 by 4, which is equal to 2.5. Done. This is only calculation, right? Why you are taking this much of time? Right? Now, so now the same thing I'm doing here. See, df of x dot variance. That variance means I'm going to get 2.5. By default, it is going to select the sample. By default, it is going to give the sample variance. Now, sir, I don't want the sample variance. I want the population variance. Whatever the population variance is there, that I want. That is population variance. If you want population variance, df of x dot variance, inside this, you have to take DDOF, degrees of freedom is equal to 0. Here, by default, if you open the shift tab, by default, it is going to consider the DDOF value is equal to 1. By default, n minus 1. It is going to take n minus 1. I don't want n minus 1, n minus 0 I want. N minus 0 means nothing but caps lock n. So I want the DDOF is equal to 0. If I write DD of OF is equal to 0, I'll get the population variance. Is that clear? By default, it is going to consider the DDOF is equal to 1. That is number of degrees of freedom, n minus 1. It is going to consider n minus 1 by default. So we are going to get the sample variance and sample standard, population variance. Next, similarly, if you want sample, what is the sample standard deviation? Sample standard deviation is nothing but df of x variable, whatever the x variable you are having, dot standard deviation. By default, it is going to consider once again DDOF is equal to 1 only. Again, it is going to take the square root of 2.5. Square root of 2.5 is 1.58. Now, what is the square root of 2? Population, similarly, population, this is sample standard deviation. This is the sample standard deviation. Similarly, you are having the population standard deviation. Population standard deviation. For population standard deviation, what is the formula? Variance of the population variance. Variance is 2. Square root of 2 is 1.414. So just what you have to write, DDOF is equal to 0. You are going to get 1.414, square root of 2. Is that clear? Clear, guys? Minimum value, maximum value, everything are clear or anything? Clear? Next, you want to calculate the quartiles. So DF of X variable. For the X variable, you calculated the minimum value, maximum value. Now you want to calculate the quartile. Okay. Quartile. And with respect to 0.25. Okay. So you are going to get, what is the, so this one, what is Q1 value of this one for this data set? This is the minimum value. This is the median value. This is the maximum value. Q3 is 4. Q1 is 2 only. 2 only, right? Q1 value. Q2 values, that is median values 3. Q3 values 4. Maximum values 5. So this is the Q1 value. How to calculate the Q1 value is just you have to ask quantile of 0.25. Okay, this is called as Q1. Similarly, if you want to calculate the Q2, how to calculate Q2? Q2 is nothing but median. If you ask median also no problem. If you ask here 0.5 also no problem. That is nothing but 50% of the data. This is called as Q2. And similarly, Q3. If you want to calculate the Q3, just what you have to do? You have to write the 0.75. 0.75 gives you the Q3 value. This is the Q3. Now, how to calculate the interquartile range? IQR. That is nothing but Q3, that is this one, minus this one, Q1. Whatever the Q1 is there, this one. That is 4 minus 1, which is nothing but 4 minus 2, which is nothing but 2. Is that clear? Interquartile range is clear. Next, we want to calculate the skewness, whether the data is skewed or not. So DF of X. For DF of X, you consider the DF of X variable dot skew. So dot skew, give the skewness value. The skewness is equal to 0. Means it is a perfectly normally distributed. That is the meaning of that one. Perfect normal distribution. If the skewness is 0, if the skewness is negative value, left skewed. If the skewness is positive value, right skewed. If the skewness is 0, normally distributed. In this way, we are going to calculate the skewness. Right? Is that clear, guys? Skewness. This gives the skewness. Next, if you want to calculate the covariance. Now, what is the covariance? How to calculate the covariance? Covariance is nothing but both of them. That is X1. Just calculate the covariance of this one. So for you, I will make the simplified instead of 6. This one, let us take as 10 plus 20, 30, 30 plus 10, 40, 40 plus 20. Let us take this one as 20. So that for your calculation will be easy. To make your calculation easy, I have taken the data like that. Please calculate the covariance of X comma Y. Sigma of X minus X bar into Y minus Y bar divided by N minus 1. If it is sample data. If it is population data, divide by N. That is first x bar, that is 3, 1 minus 3, minus 2, minus 1, 0, plus 1, plus 2. This is called as x minus x bar. Y bar, what is y bar value? 24, 44, 50, 60, 60 by 5, 12. Y bar is 12. Now y minus y bar, what is y minus y bar? That is 10 minus 12, minus 2, 14 minus 2, plus 2, 20 minus 12, plus 8, 6 minus 12, minus 6, 10 minus 12, minus 2. Right? This is y minus y bar. Now what you are going to do? X minus x bar into y minus y bar. That is minus 2 into minus 2, plus 4, minus 2 into plus 2, minus 2, 0, minus 6, minus 4. Now what is the sum? Sum is nothing but minus 8. The sum is nothing but minus 8. Now, covariance formula is sigma of x minus x bar into y minus y bar divided by n minus 1. That is nothing but minus 8 divided by 5 minus 1, which is nothing but 4, which is minus 2. This is the covariance, right? The covariance between the two variables, whatever the two variables I am having. The same thing, if I ask the covariance, I'm going to get the same answer. Covariance of two variables, which is nothing but 2, right? So here, if you observe this one, whatever the data set, df of covariance, if I apply the df of covariance, it is showing the minus 2. That is variance of x comma y. Covariance of x comma y is minus 2. Covariance of y comma x is also minus 2. Then what is this one? It is showing 2.5. What is 2.5? Variance of covariance of x comma x. Covariance of x comma x is nothing but variance of x. This is covariance of y comma y. Y comma y covariance is nothing but variance of y. This is variance of x value. This is variance of y value. These two are covariance of y values. This is a matrix. You are getting a matrix as the output. Is that clear? You are getting the output as a matrix. So in the matrix, the first value is covariance of x comma x. Covariance of x comma x is nothing but variance of x. Covariance of x comma y. This is covariance of y comma x. This is covariance of y comma y. Covariance of y comma y is nothing but variance of y. Is that clear, guys? Next, correlation. What is meant by correlation? What is meant by correlation? Covariance divided by sigma x into sigma y. So just if you ask the same thing, that is df dot core. Okay, if you ask df dot correlation, you are going to get the correlation matrix like this, where if you observe the first one, covariance of correlation of x comma x is 1. Covariance of y comma y is 1. So diagonal values is going to be 1. And the upper triangle matrix and lower triangle matrix will be the same. Right? Clear? How to calculate the covariance and correlation? Just take this small data set. For this small data set, you do one by one, step by step. Whatever I'm doing, whatever the things are there, everything you do manually. You only calculate what is for this data set, what is the variance, covariance of x comma x, covariance of x comma y, covariance of y comma x, covariance of y comma y. You only calculate one by one. Take a small data set of your choice. Any small data set of your choice. If you select a simple numbers, calculations will be simple. If you select a complex, some different numbers, for example, instead of here 20, 21 you have selected. What happens? The average is going to be, the total will be 61 divided by 5. 61 divided by 5 means 12.2. Now what happens? 10 minus 12.2 minus 2.2. For minus 2.2 whole square, if you have to do means you have to open the calculator. Minus 2 whole square means 4. Everything will be done easily. Minus 2.2 whole square means we have to open the calculator. So instead of opening the calculator, I want to do the simple work. For doing the simple work, I have selected the simple data. Whatever the data you write, like that flow in the flow, whatever the numbers you get, if you write means you have to open the calculator. That is the only additional you have to do. Nothing special will be there. In the interview, some interviews will be there, like me. They'll ask, take a sample data of your choice. Can you show the correlation calculation step by step, please? They'll ask. Everyone knows this formula because just simply writing df.core, you'll get the correlation matrix. Code is very simple now. Code is very simple, right? How you got this one? How you got these 4 values? Tell me the concept of 4 values. Can you calculate all these 4 values one by one in front of me? I'll ask like this. If he is able to calculate, miss, he is having that knowledge. No, sir. I know just my trainer has told df.core only, miss. Okay. I understand that what type of student you are. I mean, what type of person you are. Without knowing what is the backend or how the values has came, just blindly you are writing the formulas. You are called as coding monkey. Monkeys will do like that. Whatever we train, they will do like that as it is. That is the internal feeling of the companies. For them, their separate name is there. They are called as coding monkeys. Coding monkeys means in my office also one person is there. He is called as coding monkey. He'll write the code, but he'll not explain the code. How he has written also, he'll not explain. Why he has written also, he'll not explain, but he'll write the code. Whether he will write or the others will write, that is secondary, but he'll write. He'll show us. He will show us the code. If you ask from where you got this code, miss, huh? Hey, why all these things? You are getting the answer now. He'll say like this. Project manager knows about him. Team leaders know about him. Team members know about him. Everyone knows about him. Still, we'll bear him because if you remove suddenly, we can't hide the same person and we can't give the knowledge till now whatever we have completed. That is double work. Instead of that, bearing him is best. Till now, when we'll bear him, once this project is completed, he also knows, we also know that he is going to be. Once our work is completed, we'll remove him. Obviously, we'll remove him. Right? We understand clearly. But suddenly, if you remove his replacement is difficult. We have to tell that justification to the client. Why we have removed him in our team. Because he is paying the amount now, finally. He knows everyone. How many team members are there, who are working, everything. The client knows. Overview he knows, not exactly profile, individual profile, how many lines of code he has written, that they don't know. But how many members are working in a team and what are the names, that they knows. If someone has left from that particular team, means we have to intimate to the client also that this person has left. They'll ask the reason. If you say that coding monkey, he's a coding monkey, he don't know anything, just he is writing the code, means, Ray, your hiring process is that much of waste. Your HR is that much of waste. They'll get a bad impression on the HR. All these things, by keeping in the mind, everything will be silent till the project is completed. Once the project is completed, bye. Simply will remove him. So don't be as a coding monkey. Right? Understand the code behind that and what is the reason behind that. I told you relation between x and x. The formula wise also I have told you the reason. With respect to by showing the formula also, covariance of x comma x, why it is going to be 1 also I have shown you the reason. That is covariance of x comma x means nothing but variance of x. The numerator is going to be the variance of x divided by sigma x into sigma x. Sigma x into sigma x is going to be variance of x. Variance of x divided by variance of x. Automatically it is going to be 1. That is the reason why it is 1. Okay. Formula wise. Theoretical, now conceptually, what is the relation, correlation, how the correlation is going to be 1 means for that single variable, what would be the relation to himself? To himself, what would be the relation? Everything will be the same, right? That is 100%. Right? Is that clear? Correlation and covariance is clear. Any questions? If you have any questions, you can ask. What are the questions you are having? And how to calculate the z-score? X minus mu divided by sigma. After calculating the z-score, now if you have to open the z table. Now in the companies, are we going to open the z table? No. We are going to use this one. How to calculate the probability using the z-score, miss? So just open the z table. just open the Z table. So in the Z table, ztable.net. For example, here in the Z table, I'm having some value called as minus 1.11. For minus 1.11, what is the answer, guys? From this table, minus 1.11. 11, this is 1 point minus 1.11 is 0.13500, right? This is the value, right? The same thing you are going to get in the Python by using from SciPy, we have to import the stats. Stats.norm. Norm means normal distribution. And CDF. CDF means cumulative density function of minus cumulative density function of minus 1.11. Answer is 0.11349. 49 means nothing but 5. Same. The same thing in the Z table, whatever we are having, the same thing we are going to write here. And you will get the Z, whatever the probability in the Z table is that we are going to get here. How we are going to get means CDF. What is meant by CDF means cumulative density function. Now, what is the meaning of cumulative density function? What is the meaning of cumulative density function? Let me explain what is meant by cumulative density function. From 0 to 10, this is 0.2 probability. From 10 to 20, you are having 0.5 as the probability. From 20 to 30, you are having the probability of 0.1. From 30 to 40, or let us take like this, 65. $60, $80. So I'll take this one as 0.55, 75, 90, and 10. So 30 to 40 is 0.10. So completed. Okay. Now total is 100. Probability is 100. Is that okay? This diagram is okay for everyone. Now, what is the probability between 0 to 10? What is the answer of probability? 0.2. Now, if I ask what is the probability from 0 to 30, what is the answer? That is 0.2 plus 0.55 plus 0.15. Means I'm asking up to here, what is the probability? Means you are accumulating 3 probabilities. That is called as cumulative probability. Cumulative probability is called as cumulative density. Now it is clear now what is meant by cumulative density. So you are calculating in the Z score in the Z table, whatever the Z table is there. In the Z table, you are calculating for certain distance. You are calculating the here up to here. You are calculating all these things. Means you are combining every probability up to that. Whatever the probabilities are there, you are combining everything. You are calculating a Z score of, for example, I'm calculating a Z score of which is of this one. That this is assume that this is 2.2. This is the G score. For this G score, what I'm going to do? I'm calculating everything from here to here. Everything I'm calculating. That is cumulative. Complete cumulative I'm doing. Up to that, whatever the number of bars are there, every bar I'm attaching. That is called as cumulative density. That is called as cumulative probability. Is that clear now? What is cumulative probability? Right? So, if you take like this, same example, once again, I'm showing you. Same example. In this example, if you take the probabilities between 0 to 10, if you take a probability between 0 to 10, the probability is equal to 0.2. Probability between 10 to 20, if you take, it is 0.55. 20 to 30, it is 0.15. 30 to 40, if you take, then it is 0.10. This is the normal probabilities. Now, cumulative probabilities. Cumulative probabilities means up to 10. Up to 10, what is the cumulative? 0.2. Up to 20, what is cumulative? 0.75. Up to 30. Up to 30, what is the cumulative? 0.9. Up to 40, what is the cumulative? 1. This is called as cumulative from the starting to end. Now, if you want from 10 to 40, 10 to 40, this area, you're combining that one. That area you're combining. Combining the multiple probabilities is called as cumulative probability. Is that clear? Cumulative probability means combining. So here, the same thing in the z-score also. For example, you are calculating some z-score here, means here you are combining all these things. In between whatever the bars are there, everything you are going to combine. That is the reason it is called as cumulative probability. In the z-score, whatever the probability you are observing, these all the probabilities are cumulative probabilities only. Every probability is a cumulative probability. So in the XTX example, whatever the question they have given, that is chemistry exam marks, where the average of chemistry exam marks is 60 and the standard deviation is 10. What is the probability of X less than 49? So you have taken for 49, this one. Less than 49 means 10 to 20, 20 to 30, 30 to 40, 40 to 49. Everything you are combining, right? Multiple probabilities you are combining. These are all the probabilities you are combining. Left side area, everything you are combining, which is called as cumulative probability. Is that clear? It is not even single graph. It is not a single bar, right? From 0 to 49, it is not a single bar, right? It is multiple bars. So the multiple bars will be combined. Multiple probabilities will be combined. So always whatever in the Z table you are going to get, everything is a cumulative probability only. So that cumulative probability, how to calculate in the Python means by using the CDF. Cumulative density function. CDF means cumulative density function. Right? Give any value of your choice. Just for example, you try for minus 1.54. Minus 1.54. What is minus 1.54? Minus 1.5 is this one. 4 means this one. This is the answer, which is 0.06178. 0.06178 for minus 1.54. Let us try the same thing in the pandas. Minus 1.54. Right? Same answer you have got. Both will be the same. From that only this one was created. From Z table, this was created. Okay. In the companies, we'll use this one, not the Z table. We'll not open the Z table. Why we have opened the Z table and then why we have done this? In the certification, they'll give the table. They'll not give the Python. To apply this formula, they'll not give the Python. They'll not give the Jupyter notebook for us. Now, from this table, if I tell the probability, can you identify the Z-score? If I tell the probability, can you identify the Z-score? So the probability is 0.36. Probability is 0.66. Where the probability of 0.36 is there? What is the value of 0.36? 0.3838, 36, 363, 369. 36 means 0.359, which is almost close to up to 2 decimals. This one. What is the value of Z-score of this one? Minus 0.36 will give the probability of 0.36. Both are giving same value. Let us don't get confused. Let us try with one more. I want the probability of 0.05. This is my required probability. Then where is that one? 0.05, 0.6555. Yes. So what is that one? Minus 1.64. For minus 1.64, you are going to get 0.05. So now, how you calculate it, you have checked in the Z table now. The same thing, how I can get in the Python means by using the PPF. By writing the PPF, so here if I write 0.05, it will give the Z-score as the output. PPF will give the Z-score as the output. If I give Z-score as the input, I will get the P-value as the output. Then it is called as CDF. Clear? So how to calculate everything in the Python? Is that clear? Using the pandas. So that is the end of the session for today. and I'll upload this one, and please practice. Okay, do the manual at the same time Python. Both of them you do simultaneously one by one. First you